Okay, so this is a video on those 12 little multiple choice questions. It can be a little bit confusing, so hopefully I can help you here. So there's a lighting store, and you're getting light bulbs, right? And you hear that some of them are defective. So you want to take a sample and you want to test them out. So the sample that you took was from the last truck. So a truck just delivered, whatever, 10,000, 20,000 light bulbs. I don't know how many they delivered. And you took from that truck, okay, from that delivery, you took 10 light bulbs. So I'm going to draw it, I guess. I don't know if it makes any sense. Here's the truck, right? And it delivered your last delivery. So your last delivery is here. And from this truck, you took 10 light bulbs. You randomly selected 10 light bulbs from this inside this truck, right? And to see if they're defective, and you tested them. So if this obviously is a sample, right? You took a sample. What was the population? All right, so what was the population? Where do you take that sample from? So you took that sample, and obviously that's going to be um, not all the light bulbs delivered to the company this month, not the defective light bulbs, not all the light bulbs delivered to the company. That's not your population. But your population is this, right? You took away from the last delivery truck, so it has to be letter B. Okay, so where are you taking that sample from? Okay, you took that sample from this population. It was limited to what's inside the truck. Okay, so 1 is B. 2, in order to determine the number of hours of homework that a grade 10 student at Cedar Valley does each week, right? Elaine selects 25 grade 10 students at school and asks them to fill a survey. Identify the population. So, and it says here that the population, so she wants to do what? A survey based on who? Grade 10 students. So she wants to see how long or how many hours they spend on homework. And your population is, sorry, I'm underlining the wrong thing. What population? Oh, actually, grade 10 students where? At Cedar Valley High School. So that's your population. All the grade 10 students at Cedar Valley High School, right? And from there, she pulled 25 students uh, and got the sample, right? Got the what do you call? And asked them how many hours they spend on homework. So 25 is definitely your random sample. So what was the population? The population definitely has not all the grades, but she's just looking at a certain population. A certain population would be B. Okay, all the students in grade 10 at Cedar Valley High School. Okay. 2 and 3 actually got me confused for a little bit because I thought it was the same question, but it's not. It's a little bit different. So again, identify in order to determine the number of hours of homework again that a grade 10 student at Cedar Valley High School does each week. Elaine selects a random sample of 25 25 grade 10 students. So who is the sample? Well, it tells you right away, right? We know from the previous question that the whole population was grade 10 students at Cedar Valley High School. And she took a sample from all the grade 10. She pulled out 25 grade 10 students, and there is your sample right here. So the sample would be A, the 25 students selected, right? Because those are the sample, not the students in grade 10, not all the students. Remember, sample is a random part. It's a part of the population, right? So the 25 students are part of that population, and the population is the whole of grade 10. 4, a researcher wants to determine the percentage of teenagers who are left-handed. She gives a survey to 50 randomly selected students enrolled in grade 10 at the nearby high school. Identify the sample. So, who's your population here? Okay, the population is all the all the teenagers. And out of the whole, so if your population, so we've put this in a big circle, right? Remember, or a big picture. So remember that exercise we did the other day. So imagine a picture here with all the teenagers. And we're going to take a sample, right? And we're going to take a sample. What can I pull out of all the teenagers? And the teenagers that we pulled out are the 50 randomly selected. Okay, so the 50 students here. That's the sample that I took. Can't be the teenagers attending the local school. Can't be the teenagers. That makes no sense. Can't be the students in grade 10. I mean, not all the students. The sample that she took was the 50. Okay, that she took. And hang on 1 second. The sample, I apologize for this. The sample that she took, okay, the specific sample that she took, I'm sorry, the answer is C. It's 50 students, but to be more precise, the students in grade 10 at the local school. That was the sample that she took. So the sample, the teenagers, okay, and the sample she took was from the teenagers in grade 10 at the local school. My apologies for that. 5. A popular writer in the local newspaper asks his readers, should teenage drivers be restricted to driving from 6 a.m. to 11 p.m.? Meaning they can't drive, all right, from 6 a.m. to 11. 80% of the readers who wrote in said there should be restrictions. Identify the sample. So first of all, who's the population? The population, okay, population is the readers of the writer. So here's everybody who reads the column of that writer, okay? And then did everybody respond back? Okay. So the sample here is all the people that read and wrote back, right? Because there are people who read and didn't write back, and there are people who read and wrote back. So the sample here, this is based 80%. This is 80% of who? Of all the people who read and wrote to the writer. Okay, so that's the sample here. Whereas, again, readers, and there could have been readers of the writer, people who read what he writes, but didn't happen to read that column that particular day. Okay, so the readers of the writer is the whole of the whole thing, and out of that, a certain group, and that certain group, the subset, right? The certain group here are the readers who wrote back. Okay, so that would have been your answer, which is D. 6. John wants to know how many people will go to the holiday fireworks this weekend. He wants to estimate. He wants his estimate to be as accurate as possible. Which method of surveying would give John the most accurate estimate? Okay, survey the first 50 people purchasing grocery at the supermarket. No, because the first people coming in could be a whole group, right? The same group. So that's why you can't survey the first 50 in a row, like one after the other. Maybe you skip every 5, every 7, or every 8, every third customer. Because what if the first 10 people are all from the first family or from the same group, or they share the same activity? Okay, so that can't be it. B. Randomly survey 50 parents with small children at the park. Again, biased. If you have small children, they probably will like holiday fireworks, or you're most likely to go to this firework event. So that would definitely not be random. Survey 50 shoppers at the entrances of 5 different shopping malls. That's not a bad idea. Okay, that seems a little bit more random. And randomly survey 50 people walking in front of his house this evening. No, but obviously that's not random. So the only one that would be fair would be letter C. 7. Marie wants to know how many students plan to attend the opening night performance of the high school play. To best predict attendance, she should conduct a random sample of the students. Okay, so she wants to know who's coming to the high school play. How would you do a survey? You would take a sample from where? From the official enrollment roster? From her gym class, which is phys ed education class? Nope. For those waiting for the bus after school? No. In the computer lab? No, because B, C, and D are selective, right? You're favoring a certain group. Like B's favoring everybody who takes the bus. C's favoring people who take gym in her class, and maybe because they're in her class, they want to see her at the play, so that's biased. So the only way to do this is A, okay, on the official enrollment roster. So you go down to the main office and you ask Ms. Miller maybe for a list of all the kids in the school, and you randomly select whatever number of students you want in your survey. Okay. 8. Do American teens like ice creams? Pretty sure they do. Research is conducting survey, and he wants to answer the question for the dairy farmers of America. He wants to survey a portion of American teens to answer the question. So this is an example of, well, obviously it's an example if you want a portion, a subset, right? A group surveying a portion of American teens. So he's not going to ask every American teen. So he wants to take a sample. So letter 8 is sample, right? You want to take a sample of the American teens and use that to predict how the whole population, the teen population, would behave. 9. Which of the following conditions must be met if a sample is to be regarded as a random sample? Remember, a random sample, you have to be, everybody has to have the same chance to be selected. Okay, that's same equal chance to be selected. It's really, really, really important. Okay, so one, each individual of the population group has an equal chance of being included in the sample. Well, yes, that's for sure. 2, every 5th person of the population group must be included in the RAM-STEM. So no, that's not true at all. Okay, it could have been every 6th, every 10th, every 12th. So that's definitely not something that must happen. A random sample must be chosen from a list of registered voters. No, I don't even know where that comes from. So that makes no sense. I mean, unless you're talking about you're taking a sample of who's going to vote for the president, and then obviously you want to take the list from registered voters. But if you want to know how many people like, I don't know, rock or hip hop and whatever other type of music, you don't need to use registered voters, a list of registered voters, right? So A1 would be the only one that matters, only one that's correct here. 10, here's a PTA store. The PTA junior high school said that they will request the school administration to change the school's mascot if 78 of the 110 PTA members approve it. You interview a random sample of 32 members and found that 23 of them approve. So first of all, he's saying that if 75 out of 110 members approve it, we're going to change the mascot. So there's 110 PTA members. 75 of them say yes, we're going to change the mascot. We have a bulldog, so imagine we change it to a cat or something. So 75 divided by 110. So that, by the way, as a percentage, it's about 68.18%. All right. So here's the thing, and again, just like we did it earlier, if we don't want to ask 110 people, right? God knows where they are right now. They're busy, they're at work, they're at home, they're doing this. So you decide to interview a random sample, good, and you selected 32 members of the PTA, and you found out that 23% of them said yes. Okay, so based on your survey, okay, so based on the smaller, you took a sample instead of 100. Again, instead of interviewing or surveying 110 people, 100 PTA members, you surveyed only 32. And based on this result, you're going to get a feeling of maybe, hey, you know what? This is going to give me an idea that if I had to interview 110 PTA members, would have they all be in favor? So 23 divided by 32 is 71%. So in your survey, okay, you got 71%. 71.82 or 88%. Okay, so what can we say based on this? So, no, do you think no, the parents are not going to approve? In the present survey, everyone did not approve it. No. In the little survey that you did, you got most parents said they want to change the mascot. In the little, cannot decide because the sample does not include all parents? No. The sample is not supposed to include all the parents. The sample is only, include a fair number, all right, that you can use. C, yes, because everybody likes change. That makes no sense, so let's just ignore that. And D, based on the sample that you took, okay, based on the 32 PTA parents that you took, almost 80% will approve it. Well, I think it's D because 80% is not that far, but you got a good inclination that hey, based on the survey that I took, I think most parents will approve the change to a different mascot, and I think D is the answer. Okay. 11. The council of the academy say that we request the school to change the passing time between class periods. So the time that you are in the hallway from period 2 to period 2 to period 3, they're going to change it from 4 to 5 minutes if 800 students approve it. So I'm pretty sure most kids would say yes to this. Okay, so the academy has 1,400 students. And obviously, you're not going to interview 1,400 kids and ask them, hey, do you think we need more time in the hallway? Yes or no? So you take a sample again, random sample, use a name generator or something, and you got 150 students. Okay, so that's what this is saying. So, and you found out that 85 out of the 150 students that you talked to said, yeah, we want more minutes in the hallway. So 85 divided by 150, that's about 56%. I'm rounding it, okay? But what do we need? We need 800 kids to approve it. So what's 800 out of 1,400? So what did we actually need? Divided by 1,400. We need a 57% approval. So the administration, Ms. Miller, Ms. Bryan, said, hey guys, if 57% of these kids say yes, we'll change it from 4 to 5 minutes, right? So if we were to ask every single kid in that school, that meant we needed 800 people to say yes. But like I said, we didn't ask everybody. We only asked 150 students. And out of the 150 students, 85 said yes. So that's pretty close, right? Pretty close. So which of these statements can we agree with? No, based on the sample, 800 students may not approve it. Actually, no. Based on our sample, 56% did approve it. So if I actually had asked 1,400 students, I think I would have gotten more or less the same answer. So A is out. No, in the survey sample, everyone did not approve it. No, not everyone. Well, you're right. Everyone did not approve it, but a fair amount, more than half, did approve it. Cannot decide because the sample does not include all the students. Well, the sample does not supposed to include all the students. Okay. Did I do something wrong? Because D doesn't make any sense. Yes, because everyone likes to talk in the hallway, so that's out. Am I missing something? So yeah, divided by 1,400, 57%. 85 divided by 150, 56. So, based on the sample, 800 students may not approve it. Wow, that's really close. I mean, the only answer that, wow, 11, well, it's not A, that makes no sense. C also does not make, it's not making any sense because it's sample, right? We're taking a sample because we don't want to interview everybody. So I had A in the beginning. No, based on the sample, 800 students may not approve it. No, student in the sample, in the survey, everyone did not approve it. Okay, so B, no, in the survey sample, everyone did not approve it. That's not true. Some people did approve it in our survey that we took, right? We asked 150 kids, and quite more than half said yes, they were going to change from 4 to 5 minutes. So the only one that makes sense is A. Based on the sample, 800 students may not approve it. Yeah. So again, the sample was not crazy. Like 80% of the people that we surveyed said yes. Even on the little survey that we took, it was still 56%. So yeah, I think it's going back. A, it's the only one that makes any sense. 12. There are 1,000 marbles in the bag and the box. Jamie took a scoop of the marbles. He counted 25 red marbles, 10 green, and 5 blue. If the scoop was a good sample of the marbles in the large box, how many red marbles would you expect to find in the large box? All right. So I took a scoop, 25 25 marbles, and in that 25 marbles, scoop. So scoop had 25, 10 and 5. So that is 35, 40 marbles. So he took 40 marbles out total. And out of the 40 marbles, 25 were red. So this is saying to me that in that bag, it looks like, if this is true, if this relationship here is true, that more than half of the bag will be red, right? Because if I took 40 and 25 are red, more than half is red, right? So let's take that number and multiply it by 1,000. See if we're correct. So if I multiply by 1,000, put this over 1 if you like. 25 times 1,000, 2,500. 40 times 1 is 40. You're going to divide that. And hang on 1 second. Okay, sorry, this is 1,000. And then we're going to divide it by 40. So if there's 1,000 marbles in the bag, and if what I took, that little sample that I took, is a good representation, it's a real representation of the color ratio in the bag, I am going to expect that there's going to be about 625 red marbles in the bag. Okay. If you have questions, write them down, and we'll talk about it in class. Okay, that's it.